All right, so the first part of this activity, guys, just taking a few notes about the basic form of an exponential graph. So the basic form of any exponential graph is going to have the variables a, b to the x plus k. A, b, and k are going to end up being replaced by numbers. So the exponential here, that b is raised to the x power. So this activity is going to help you discover the effects of a, b, and k on the graph using Desmos and some sliders. But first, let's talk about what a horizontal asymptote is. So exponential graphs are going to have what's called a horizontal asymptote. And for those of you that have never heard of this before, these are lines that the graph will approach or get really, really close to, but technically they never actually cross. So take a look at what this kind of looks like. So let's say we wanted to graph the equation 4 times 2 to the x. Let's just use a table of values. So in other words, let's plug in x equals negative 3. So in other words, let's do y equals 4 times 2 to the negative third power. Let's see what that equals. So I would just go to a calculator, and so we'll have 4 times 2 to the negative third power. And you can kind of see over here, when I put that in, that's zero point 0.5. So that equals zero point 0.5. So let's plot the point negative 3.5. Let's plug in negative 2. So 4, 2 to the negative second. So we'll go back to so we have 4, 2 raised to the negative 2. Let's see what that equals. That equals 1. So apply the point negative 2, 1. Y equals 4, 2 to the negative first. So let's plug that in. So 4 times 2 to the negative first power. And that equals 2. All right, so we now have the point negative 1, 2. Let's plug in 0. All right, so y equals 4 times 2 to the 0. I actually know 2 to the 0 is 1, and 1 times 4 is 4, so we have the point 0, 1, 2, 3, 4. We'll plug in the point 1. 4 times 2 to the first. Well, 2 to the first is 2, times 4 is 8. So we have the point 1, 1, 2, 3, 4, 5, 6, 7, 8. And then finally, y equals 4 times 2 squared. 2 squared is 4. 4 times 4 is 16. So 2 to the 16th, probably something way up here. So you've probably seen graphs that look like this before. But what you should notice right here is that the graph is getting really, really close to the x-axis. The x-axis is actually the asymptote. But that's also what's called the line y equals 0, right? So we look at some of the other characteristics of this graph. The y-intercept, that's the point 0, 4. The domain, remember that's the x value. So this will go anywhere from negative infinity up to infinity, right? The graph's going to keep going to the left, and it's going to keep going to the right. Now range, you see this dotted line. It's going to get really, really close to 0, but never cross it. And then it's going to keep going up forever. Here we actually are going to use parentheses with 0 because it never actually touches it. Now if I open a Desmos file, I can kind of show you how this works. So let's graph the equation y equals 4 times 2 to the x. And what you see, right, if we, there's our y-intercept is 0, 4. And if I kind of trace some points, there's the point negative 1, 2. We found that point. Negative 2, 1. Kind of hard to get right on it. Here's my point where I did negative 3.5. But as you see, it looks like it's getting really, really close to the x-axis. But as I keep tracing this point, all of a sudden it looks like, hey, at negative 14, maybe it did touch 0. Well, that's just a function of this graph. It has certain capabilities. If I were to zoom in far enough, and I kept zooming in, zooming in, zooming in, zooming in, you can see how very, very close. Look how tiny my scale is right now. Right, my scale is showing you from negative 12 to negative 11.995. Then we get a little bit of a gap, right? It's barely above the y-axis. So it's getting very, 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 very close to the x-axis, but it's never actually going to cross it. That's the interesting thing about asymptotes. So let's go back and try one more problem. What if we did 2 to the x minus 2? So let's plug in y equals 2 to the negative third minus 2. I'm going to go back to the calculator and let it kind of do the work for me. So we have 2 to the negative third minus 2. Excuse me, that's not what I want. 2 to the negative third. I want to close those parentheses out. Minus 2. I want to make sure that minus 2 is not up in the parentheses. So negative 1.875. Let's plug in y equals 2 to the negative 2 minus 2. Here again, make sure that you close out those parentheses. I actually have to hit the over button. Negative 1.75. Y equals 2 to the negative first minus 2. So let's go 2 raised to the negative 1. Oh, excuse me. Minus 2. Negative 1.5. 2 raised to the 0 minus 2. Well, I know 2 to the 0 is 1 minus 2 is negative 2. 2 to the first minus 2. Well, 2 to the first is 2 minus 2 is 0. So 0, 1. 2 squared is 4 minus 2 is 2. 2 to the third is 8 minus 2 is 6. So let's plot these points. So negative 3, negative 1.875, negative 1.75, negative 1.5. Hold on just a moment. Oh, I see what I did wrong. This is not negative 2. 2 to the 0 is 1. 1 minus 2 is negative 1. So 0, negative 1, 1, 0, 2, 2, and then 3, 1, 2, 3, 4, 5, 6. So here, the y-intercept changed to 0, negative 1. The domain again, it's going to go as far to the left as it wants, as far to the right. But where does it look like the graph's getting really close to? If you look very closely, it looks like it's getting really, really close to the line y equals negative 2, which means the range, this thing will go really close to negative 2, and it'll go all the way to infinity. So what you guys are going to start to see is really what are these kind of effects that things like subtracting 2 at the end, or what happens when I multiply by a number in the front versus when I don't, right? There's kind of a 1 in the front. What happens when I change that b value? That's what this activity over the next 3 pages is going to walk you guys through. So open up a window in Desmos and follow the instructions, and good luck.